Welcome back to another Melon Auto Diagnostics video. Today we have a 2023 Nissan Rogue, and the complaint with this vehicle is the check engine light was on. Alright, so I've actually messed up real bad with this one because I had to clear the codes for I had to move a car came in, I brought it in the bay. Then I had to move it because there was another car that I was blocking, so I had to actually turn the vehicle on. But the battery died because another tech left the ignition on by accident. So then I had to clear some codes so that the car would let me drive, because it went into like some power reduced mode, some weird stuff. So I actually had to clear the code. But luckily, initially I was able to print out the codes. The one we're worried about right now is that PE0181, which is a fuel temperature sensor, and it was current at the time, but I mean it hasn't came back on since I cleared it. So we're just gonna do some circuit testing and look at some data monitoring and see what we can find. All right, so I have some data here pulled up. This is pretty much how the ECM determines that there's a fault with honestly any temp sensor, I would say, on Nissans. It kind of just compares the coolant intake, air temp, fuel temp, and the engine oil temp. Right now the vehicle is running because, like I said before, the battery died. But when I was initially looking at this car, I promise you the coolant temp, intake temp, engine oil temp were all at within 5 degrees of each other, and they were in the low 30s. The car was sitting outside. I live in a very cold state, so right now it's freezing outside, and so obviously, you know, your temperatures are going to drop. And I brought it in the shop and scanned it and looked at some data real quick, and the coolant temp was maybe 29, the intake temp was like 34. The fuel temp sensor was at 73, just like it is right now. And the engine temp was, I believe it was like 31. Like I said, I apologize again. You guys are gonna have to take my word for it, but those were my readings. So obviously the fuel temp sensor stood out to me, and we did have a code for it. So we're gonna look at a wiring diagram now and see what we can do to condemn anything. Now I will admit, these vehicles do have a common issue with these fuel pumps, because the temp sensor for the fuel is part of the fuel pump itself, the fuel pump sending unit. Now I do believe that some models have it separately, have that temperature sensor separately, but I've yet to run across a car that it's separate. It's always, or at least for me, it's always been part of that pump. All right, so we have the wiring diagram pulled up here, and just kind of want to explain how this temperature sensor works. It works like any other temperature sensor, to be honest, just like your coolant temp, oil temp, whatever. All it is you have 5 volts coming out of the ECM, and it's going through a resistor in the sensor. Now that resistance in the sensor will change when temperature changes. What happens is there's another resistor internal to the ECM. So what you have now is 2 resistors in series. So you have 5 volts through a resistor and coming out to this resistor here, which is the sensor. And as the resistance changes in the sensor, right, with temperature, this voltage will also change. Well, the way I was taught this concept was, if you have a water hose and you squeeze it on 2 ends with your palms, and you kind of just apply pressure with your left or your right, that pressure in between your 2 palms will change as you're squeezing or letting off. So it's kind of this, I know it's water, but it's kind of the same concept here. You have 1 resistor in here, 1 resistor in here. This one's changing with temperature, so that voltage in between them is changing. This voltage is not capable of carrying amperage. It is what they call bias voltage. So pretty simple. This is pretty much how all temperature sensors work across all brands pretty much. So yeah, that's pretty much it. So I'm gonna take the back seats out, or the back seat, the back bench. I'm gonna take that out, I'm gonna go to the connectors, and we're gonna do some testing right there. Alright, so I have the back seats removed. There's a cover here I had to take off. Our fuel temperature sensor connector is right here. There's 2 wire pins. So you got the volt feed and then that 1 wire going to the ECM for the signal. Quick test here. I'm gonna unplug this and I'm gonna have you guys reading here. Unplugged, and it's negative 47 degrees Fahrenheit. So that already tells me a lot. I'm gonna plug it back in. If it ever wants to plug back in, there it goes, and we're back at 73. So yeah, that already tells me a lot. I'm gonna do the what I'm gonna do now is I'm gonna ground that circuit, that wire, through a light. Not direct ground. I don't think I'll hurt anything anyway because it's through a resistor in DCM, but right, safety third anyway. So I'm just gonna do that. So I'm gonna back pin, because they make this thing so annoying. So I'm gonna put this pin here on this brown and white wire. Alright, so I'm gonna put my test light to ground. Hopefully I'm making good connection there. We're gonna just touch that probe. Alright, so I had to actually step away for a bit, but we're back on this. Yeah, I don't know if you guys can, I can actually bring that over here. Alright, so readjusted here. We're reading 79. I did leave it running while I turned it on before I walked away, just so my battery voltage wouldn't get too low. So we're reading 79 now. We still have that pin in there, and I'm still hooked up to ground. I'm gonna touch that back probe pin. We're making good contact, and we're reading, come on, 331 degrees Fahrenheit. So now what we did was we bypassed the sensor, and we're putting those 5 volts to ground with our test light, through our test light, which obviously this test light is very has very low resistance compared to the resistor in the ECM, and the ECM interprets that as very high temperature. Alright, so after doing those tests back there, I know this is kind of backwards, but like I said, we see these so often that we really don't go too crazy with them. So the diagnostic procedure for these are pretty much, you're checking the 5 volts at the back there, right, which was that pin 8, and we're checking continuity to the ECM, and then it has you check continuity to the ECM on the other wire. If all that checks out, then you do a component inspection, which is another hyperlink. And this is such a broad spec. The reason why I wanted to show you guys the diagnostic procedure is because with what I did, I believe I eliminated almost every variable, right? And I think it's safe to condemn the fuel pump as being bad. Initially, when I compared the intake, the engine, and the coolant, they were all at around 30 degrees Fahrenheit, and my fuel temp was at 73. Mind you, the car was sitting outside. yes, the fuel tank is very protected and very, very sealed, but there's no way it was 80 degrees in that tank, and that's why we're setting the fault. But if we had higher resistance on this wire here, let's say a corroded connector, we'd actually have low readings, lower than normal. So can I have high resistance on that harness or wire? In theory, no, I can't. And if I did have high resistance in that wire, like I said, we'd have lower temperature readings than all the other sensors at a cold start or a cold ignition. Alright, so it is now a couple days later. The vehicle hasn't been started at all. It's been sitting here for a few days now. I have the ignition on, engine's not running. You can see that fuel temperature sensor is reading 100 degrees Fahrenheit. All the other ones are about 60, 59, within 3 to 6 degrees of each other, which is to spec. But we do have that oddball there at 100 degrees. So now I'm going to replace the fuel pump, and we're going to look at the data monitoring after the fuel pump replacement. So we'll see if we get a change there on that value here. Yeah, so see you guys after that. Alright, so new fuel pump installed, and those are our readings now. We're now reading 57 degrees Fahrenheit. Obviously it was a fuel pump out of the box, brand new, so it's gonna be a little just slightly lower than everything else, but it's still within spec. At 3 to 6 degrees of everything else, I believe, or it might be like 3 to 7, something like that. But there you have it. This is definitely a fix. I will end the video now. You guys, please go subscribe, like the video, comment any questions or concerns you may have, and I'll see you on the next vehicle repair video.